The worst crime one can commit is not murder or treason, at least in mathematics, but a simple operation, dividing by zero. Division. What is the operation of division? Division is, fundamentally, repeated subtraction. For example, x divided by y equals z essentially means y needs to be subtracted z times from x to reach 0. For instance, 6 divided by 3 yields an end result of 2, since 2 3's can be subtracted from 6 to obtain 0. The operation of division is intertwined with three numbers. They are the dividend, the divisor, and the quotient. The dividend is the number that is being divided. The divisor is the number that is dividing the dividend, whilst the quotient is the result of the operation. But what does dividing actually mean? Let us take a look at a simple example, such as cutting pieces of cake. If you slice a single cake into 3 different pieces, it suggests that each piece is a third of the cake, 1 divided by 3. 4 different pieces would be 1/4 of the cake, and so on. However, if there were no cakes and you still wanted to share pieces of cakes amongst your peers, 8 of your peers to be precise, each of your peers would get exactly nothing. By common sense, we can comprehend that they aren't going to get something if the original whole was nothing. Hence, since we started off with nothing, no matter how large the divisor becomes, the quotient will still remain 0. In the universe of mathematics, proving that 0 divided by 8 is still 0 is simple. All we have to do is identify the multiplicative inverse of the quotient. If you have any number x multiplied to another number y, you will obtain a product of z. If x times y is z, then there must be some other number a such that z times a gives a product of x. A is the multiplicative inverse of y. A fascinating pattern emerges from which we can identify that the product of a and y will always be 1. Thus, if y is the divisor of another number b, then the product of b and the multiplicative inverse of y will result with the same number. From this, we can identify that if 0 times 1 over 8 yields a product of 0, then 0 divided by 8 should equal 0. Thus, our theory of the multiplicative inverse holds true. However, all of this does not account for the fatal numerical sentence we have been avoiding for the past few minutes, setting the divisor to 0. Setting 0 as a divisor. If we had a number sentence of 0 divided by 3, it can be translated as splitting nothing into 3 parts for 3 people. Each person would receive no cake. However, if the number sentence was 3 divided by 0, it implies that 3 cakes are to be shared amongst no people. How much of a cake is a person going to indulge upon if no one is present in the first place? Mathematically, if any number x with a divisor of 0 has a quotient of y, then y times the multiplicative inverse of 0 must be x once more. Mathematics has been based around that singular axiom. Unfortunately for mathematicians, 0 appears to not have a multiplicative inverse. By definition, the multiplicative inverse of 0 multiplied by 0 must yield the product of 1, but since anything multiplied to 0 has a product of 0, our equation does not hold true. But isn't the multiplicative inverse of 0 simply 1 over 0, since the multiplicative inverse of any number is its reciprocal? If the multiplicative inverse of 0 is truly 1 over 0, then the paradox we've encountered above surfaces again. The majority of the population simply assumes that the dividend with a divisor of 0 will yield the quotient of 0 as well. If x divided by 0 is 0, then 0 times 0 must equal x. Any number multiplied by 0, including 0, yields a product of 0 as well. Since we did not start with a statement that stated x was equivalent to 0, this equation remains unsolved, and therefore x divided by 0 equals 0 is incorrect. Hypotheses and sketchy calculations. When equations cannot be comprehended easily, graphs can be consulted. A graph is any visual representation that takes in all of the domain values of x and returns a range value of y. Let us draw the graph of y equals 1 divided by x in the non-negative domain, meaning the x inputs will be non-negative integers. If we draw a table to list down some of the key points that we are to include on our graph, we find that the greater the x inputs, the less the y outputs. Conversely, the less the x inputs, the greater the y outputs. After finishing the graph, we obtain a curve known as a hyperbola. So wouldn't it be reasonable to conclude that for the number sentence y equals 1 divided by x, if x is 0, then y would be infinity? If y is infinity, this suggests that infinity times 0 is equal to 1. By now it may seem obvious that any number multiplied to 0 gives a product of 0, and hence the sentence above cannot hold true. Albeit our current numbers and proofs cannot supply evidence for the possibility of dividing by 0, what is there to hold us back from trying? To set the divisor as 0, 0 must have a multiplicative inverse. The y equals 1 divided by x graph seems to assert that for the domain value of 0, the range value is infinity. Hence, 0 times infinity equals 1. So far so good. Let's splice the operation up a bit to test its veracity. If 0 times infinity is equal to 1, then that means that 1 plus 1, or 2, is 0 times infinity plus 0 times infinity. Through what is known as the distributive property, we can rearrange the like terms in the number sentence of 0 times infinity plus 0 times infinity equals 2 to 0 times infinity equals 2. Since 0 times infinity is equal 1, and 0 times infinity equals 2 as well, this states that 1 equals 2. Since 1 equals 2, it's obviously false in our real world. 0 cannot be the divisor of a division number sentence. Conclusion. Every human on Earth loves finding out the unknown, whether this is how to overcome a maths test or discovering the anatomy of black holes. But mathematical paradoxes, such as the divide by 0 error, seem to remain stubbornly in the abyss of ignorance. All we know is that, as for now, you must never divide by 0. Some viewers may have noticed that we have sort of already uploaded a video regarding the divide by 0 error, and this is true. However, the Information Institute has come to an executive decision to remake our original video due to several errors in the video production. The old video will not be removed, but a link will be provided directing viewers to this video. In the meantime, we have reduced the diffuse nature of the old video by omitting unnecessary bits and pieces, and we have splashed a new look on the video to enhance viewers' convenience.